Hello everyone and welcome back to another project entitled as IoT based secure door lock. So initially I'll be talking about the features of my project, then I'll describe the components that I've used here, and finally I will show you the demonstration, the way the project works. So with no delay, I would like to dive into the features of my project. So over here I have designed a user interface so that a person can easily interact with the design system in order to unlock the door. And the door can be unlocked by following a number of methods. For example, by using a preset password, by using a one-time password or an OTP, which would be sent to the corresponding authorized person via SMS and via Telegram message. The door can also be unlocked by scanning authorized RFID tags. If someone wants, then he can also unlock the door by sending authorized commands from the authorized Telegram chat as well remotely from the IoT Cloud dashboard. And access to the IoT Cloud dashboard can be taken either by using the web browser or by using the Android application. So I have designed an IoT Cloud dashboard, as you can see here. The first one corresponds to the unlock button that can be pressed in order to unlock the door. The second gauge is about the lock state, which will be green if the door is locked and red if the door is unlocked. Then we have the temperature and humidity gauges that will be giving us the real-time temperature and humidity of the surroundings. And finally, we have the statistics gauge that will be telling us the time when the lock was opened and when the lock was closed. So that's all about the features of my project. And if any kind of suspicious attempts are made in order to unlock the door, for example, if someone attempts to unlock the door with incorrect passwords, if someone attempts to unlock the door with incorrect OTPs or unauthorized RFID tags, then the notification corresponding the suspicious event would be sent to the authorized person via SMS, Gmail and Telegram message. So that's all about the features of my project. In the next part, I'll be describing the components that I've used here. So as the microcontroller, I have used the ESP32 board that comes with a built-in Wi-Fi, allowing me to connect with the internet. As the GSM module, I have used the same 800L GSM module. One very important thing that you have to keep in your mind that it is not 5 volt tolerant. So you have to power it with 3.7 volts to 4.1 or 4.2 volts. That means with a single lithium-ion battery. You must ensure that your power source is capable of supplying enough current to drive the module to transmit messages and phone calls. Another thing is that it is very sensitive to power. That means if you are connecting the power source with a jumper cable to the VCC pin of the same 800L GSM module, then it may not establish on the network, blinking once in every second. So in order to avoid this problem, one thing you can do is directly solder the power source with the pin of the same 800L GSM module with the VCC pin, or directly plug in the positive terminal of the battery other than using any kind of jumpers to the VCC pin of the same 800L GSM module. As the input device, as you can see that I have a 4-channel touchpad over here that is used to design the user interface. That means you can press on these buttons to choose the method of unlocking the door. I have used a single channel touchpad over here that can be used to unlock the door from inside. That means if you simply touch on this touchpad, then the door will be unlocked from inside. I have used the DHT11 temperature plus humidity sensor module in order to sense the surrounding temperature and humidity. I have the 4x3 matrix keypad that I've used to insert the password and the OTP. But one of the problems that I faced was with the library. I mean, the library, the keypad library creates some kind of conflict with the Arduino's IoT Cloud. So I had to avoid the library and write a custom code that scans the keys of the keypad and takes the input from the person. So in my case, I was not able to use the existing library. Rather, I had to write down a code in order to scan the key which is pressed on this 4x3 matrix keypad. Over here, as the output devices, as you can see, the solenoid lock, I have the as the lock, I have the solenoid electric lock. I have the 2-channel relay module because the control signal generated by the ESP32 board are 3.3 volts, but the lock is run with around 11 to 12 volts. So to drive the high voltage load with the low voltage control signal generated by the ESP32 board, I had to use the 2-channel 5-volt relay module, and the relay can be switched with 3.3 volts. But in your case, your relay module might not be switching with 3.3 volts. So in that case, you may need to step up the voltage. You can do it by using a boost module, or you can also do it by using a BJT or a bipolar junction transistor like the NPN BGT BC547 can be a good option, I should say. Again, I have the RFID reader module over here. Another thing that you have to keep in mind while using the RFID module is to power it properly with 3.3 volt. I mean, you cannot power it with 5 volt. It is not 5 volt tolerant. So if you're powering it with 5 volts, then it may happen that the module may get damaged. I have the 20x4 LCD display including the I2C driver that allows me to work with the display with the least possible number of wires. Over here, I don't know if you can see that. Over here, I have a buzzer that is used for alerting purpose, and I also have an RGB LED. The LED will be red once the door is unlocked, once any kind of suspicious attempts are made to unlock the door, and the LED will be blinking with the green sign once the door has been unlocked with the authorized attempts. Now another thing, once you have appliances that consist of inductive coils, then it may happen that the element may supply reverse current to the rest of the components of your circuit. So in order to prevent the impact of reverse current to flow in the other components, I had to use a freewheeling diode, also known as a flyback diode. I don't know if it is visible. It's right over here. I don't know if it is visible. I have used the flyback diode in order to prevent the impact of any kind of reverse current. And most of the components over here are 5 volt or 3.3 volt tolerant. For example, the GSM module and the RFID module, they are not 5 volt tolerant, so I had to power them up separately. But all the other elements or most of the elements are 5 volt tolerant. For example, the display, the relay module, the DHT level temperature plus humidity sensor module, all these are 5 volt tolerant. But these two batteries, I mean the pair of battery that I've used here, let me show it with another color. These pair of batteries, lithium-ion batteries, they generate more than 8 volts when they're completely charged. But my appliances are not 8 volt tolerant, rather they are 5 volt tolerant. So I have to step down the generated 8 volt to 5 volt, and in order to serve that purpose, I have used the LM7805 linear voltage regulator that steps down 8 volt into 5 volt, and the generated 5 volt is thus supplied to the appliances like the DHT11, the LCD display, and the 2-channel relay module. Over here you can see that I have a battery pack of 3 cells which is used to power the solenoid electric lock. So I believe that I have described all the components that I've used here. So the very important thing that you have to keep in your mind is to connect the freewheeling diode or the flyback diode that I've shown you with the yellow circle, as you can see here. Otherwise, you might see that the LCD display may not function properly because of the reverse current. So in order to prevent the phenomena of reverse current, I have used the reverse diode, also known as the flyback diode or the freewheeling diode. So that's all about the components that I've used here. In the next part, I'm going to be showing you the demonstration, the way the project works. So right now I'd like to show you the demonstration, the way the project works. So all my components are working perfectly and I've powered up the entire system. As you can see that the GSM module is blinking once in every 3 seconds, which is a clear indication of the fact that the module is completely established on network and it is ready to transmit any kind of phone calls or SMS. You can see that the UI is also ready, and I will be using my cell phone in order to view any kind of alert or the OTP which is sent to my cell phone via SMS or Telegram. So for the sake of simplicity of demonstration, I'm rebooting the entire system from the beginning. So yes, I've reset the ESP32 board. So let's see what happens. So we will see the welcome screen, and at the same time we have also received a notification on Telegram that says that the door lock system has been booted. As you can see that the time is 8:35 and the message also got arrived at 8:35. All right. And the cloud is also updating with the real-time information, with the real-time data like the temperature, lock state, and the humidity, as you can see on my screen. So right now I'd like to unlock the door using the password. So what the screen says is enter 1 for password, enter 2 for OTP, enter 3 for RFID, and at the bottom we have the temperature and the humidity indication. So as I press on 1, I will be able to get into the password page. So I'm pressing on 1. So yes, it says that the door is locked, and enter the password. So I have to enter the preset password. So the password was 123456. So right now I would like to enter the password 123456. You can see that the lock has been unlocked. All right. So in the next part, I will be trying to enter the incorrect password and see what happens. So okay, I have to hold it a while. Yes, it has gone to the password page. So I have to enter the password. Let's enter an incorrect password and see what happens. So we have an alert, password mismatched, try again, and then it will be sending me the alerts. The first alert is probably an email. Then we will get an SMS and a Telegram alert. So the second alert is an SMS. So let's wait. And the third alert is a Telegram alert. So we have already received the Telegram alert. As you can see, suspicious unlocking attempt detected, and the SMS has not arrived yet. Oh yes, we also have an SMS, but that's that has not come right now. So the SMS has not arrived yet. Maybe that might be due to a network issue. So in the next part, I would like to show you if there was any kind of email. So let me refresh my email and see if there is an alert. So at 8:37, as you can see that we have an email saying that suspicious attempt detected to unlock the door. So I'm done with this part. In the next part, I'm going to show you the unlocking procedure with the OTP. So I have to press on 2. So sending OTP, the OTP would be sent to me on Telegram as well via SMS. So let's wait a bit. As you can see, I have received an OTP which is 930481, and I also have been sent the OTP via SMS. As you can see, door alert, the OTP is 930481. So the OTPs are same. So the OTP has been sent both on Telegram as well on my cell phone. So right now I will be trying to unlock the door, inserting the OTP 930481. So 930481. You see that the lock has been unlocked, and we must be getting back to the home page. And right now I'll be trying to enter an incorrect OTP and see if the alert works properly. So let me press on 4 to get to the OTP page. Yes, sending OTP. Please wait a bit. So I'll be sent an OTP on Telegram as well via SMS. You see I have received a new OTP via Telegram as well via SMS as well. You can see that the SMS is right over here, 368078. However, I'll be entering an incorrect OTP and see what happens. So let's enter an incorrect OTP. So as you can see that we have alert over here. The alert must also be sent to Telegram as well as SMS. So let's see if there is any alert on Telegram as well in our inbox. We have to wait a while. The second alert is being sent. The third alert is being sent. I believe that the alerts have already arrived. Let's wait a bit. Yes, as you can see that we have an alert on Telegram saying that suspicious unlocking attempt detected. The SMS has not arrived yet. That might be due to the network issue of the same 800L GSM module. However, that's not a big deal. And we would also like to check the mailbox. If the mail has arrived, let's see. So let's go to the inbox and see if the mail has arrived. As you can see, we have an email at 8:40. Currently the time is 8:40, saying that suspicious unlocking attempt detected. In the next part, I would like to unlock the door using the RFID module. So I have to press on 3, I'm sorry. So yes, it's saying me to scan my ID. Now if you want to, you can also get back to the home page from here simply by pressing on 4. So as I press on 4, as you can see that I have been I have gone back to the home menu. So right now I'd like to unlock the door using the RFID. So I will be scanning an authorized RFID, which is this card. This is an authorized one. You see that the door has been unlocked using the authorized RFID. And next I will be using the unauthorized NFC tag to unlock the door. So I'm pressing on 3 once again, and I'll be scanning the unauthorized ID. You see an unauthorized attempt, and the door hasn't been unlocked right now. So it's sending me some alerts regarding the suspicious event. So let's see if we get the alerts. The second alert will be an SMS, and the third alert will be the Telegram alert. The SMS might not be coming in properly. Oh no, it has arrived right now. So as you can see, we have the SMS saying suspicious unlocking attempt detected at 8:41. The time is 8:42 right now, and we have also got the alert on our SMS inbox, suspicious unlocking attempt detected, and there must also be sent the alert on Gmail. So let's see if there is an email. Yes, we have a new mail at 8:41, as you can see, and right now the time is 8:42. So these alerts are working perfectly. So in the next part, I'm going to show you if you can unlock the door from the IoT Cloud dashboard. So as I click on unlock on the IoT Cloud dashboard, you will see that the door lock will get unlocked, and we'll also get a corresponding alert on Telegram saying that the door has been unlocked remotely from the IoT Cloud. So let me unlock right now. You see it's been unlocked. It says that button press door unlocked from cloud. So the cloud-based feature is also working perfectly. You can also unlock the door from using the Telegram command. But if you insert an incorrect command, like anything, if you send an incorrect command, you will see that the door will not be unlocked. It will rather tell you to insert the proper command to unlock the door. As you can see, it says unknown command, use /unlock. So I will be using /unlock and see if the door gets unlocked. So let's see if it works. Yes, I've sent it, and you see that the door has been unlocked, remote access door unlocked, and we have a notification back here that the door has been unlocked from Telegram. Now I'll be trying to unlock the door from inside the home. That means in that case you don't need any kind of password, OTP or RFID scanning. You can simply touch on this touchpad and the door will be unlocked immediately. So let's see if it works. You see that the door has been unlocked, and the event has also been updated on the IoT Cloud dashboard. So that's how the project works. It's a fully practically deployable project, an industry-grade project, I should say, as it comes with multiple features, and it is indeed cost-effective, I should say as well. So that's all for now. Thanks for watching. Stay tuned for the next one. Bye for now.